Hey guys, welcome to this video on discrete probability distributions. I'm going to start by talking about what are discrete probability distributions. And for any random variable, there is a corresponding probability distribution which describes a probability that the variable will take a particular value. The probability that variable x takes a value of small x is denoted by this part just here. So, let's talk through what I've got written down so far. If x is a random variable with the possible values of little x between 1, 2, 3, 4, 5, etc., etc., up to xn, so the nth value of x, and the corresponding probabilities, so p1, p2, etc., up to probability n, such that the probability of x is going to equal the probability of the pi, or the number. So what does that basically mean? Well, it means that this value here is going to match up with this value here. That's really what all of this is saying. Long-winded way of saying it. So let's go through a few little dot points. So that the probability for any of these is going to lie between 0 and 1. So each one of these values here, the probability is going to be between 0 and 1. We can't actually have a probability of more than 1. If we had a probability of more than 1, that means that it's, or 1 or above, it means it's always going to occur. So 1 means it's always going to happen, 0 means it's never going to happen. And we can't have it happen more than it's always going to happen, which is equal to 1. So when we're talking about probabilities, we're generally talking about, we're always talking between 0 and 1. Which brings me to my next point. So the sum of all these probabilities is going to be equal to 1. When you add them all up, they've got to equal 1. If it doesn't equal 1, then something's wrong, and go back, check your working out, or it just is a wrong probability distribution. Well, that should be a 3. And finally, what all of this squiggly line stuff, so these are the curly braces that you may or may not have seen before. If you go next to P on a keyboard, shift, and you've got those two brackets up there, that's where you get them. I can't draw them properly, so I do apologise. And what this describes let's fix that up. So what this does is describe the probability distribution of x. If you can pause the video, get this written down, then we're going to talk through some examples. Alright, so hopefully you've got that written down by now. Alright, let's suppose that x is the number of heads of heads obtained when 2 coins are tossed. So we've got 2 coins, heads and tails. So you've probably used coins before to, there's a 50-50 chance whether heads or tails are going to come up. So what are the possible values of the number of heads coming up? Well, we could throw 2 coins up in the air and get no heads. We could get 1 head, or we could get 2 heads. Now, so these are the values of X. What are the corresponding probabilities of each of these? Well, if we think about it, there's 1 chance of this one happening, 2 chances of this one happening, because 1 could be heads, 1 could be tails, the first one could be tails and the first one could be heads, and there's 1 chance of this happening. So we could write out the corresponding probabilities as being 1/4, 1/2, or half, and 1/4. Alright, because realistically there is 4 different ways this could come up. So we've got coin 1 and coin 2. We could have tails, tails, heads, tails, tails and heads, and heads and heads. So, as we can see, this one, no heads, the first one here, no heads. The next 2 both have 1 head. And the final one, there's 2 heads. So that's why this middle value here is a half as compared to the others where they're a quarter. So there's 4 different cases here, so that's where we get our denominator from. We could really say that this one here is just 2/4, but we've simplified it. So 4 different cases, or 4 different ways that everything can come out, and that's where we get our over 4. So there's 1 case where there's just tails, so that's 0 heads. That's 1 head, and that is 2 heads. So that's one little example. We've also got, and I'm just going to talk about this, so please pay attention. We've got uniform discrete random variables, and what the uniform discrete random variable is that, let's write it down. Is that all values of X have the same probability. That is 1/n. We could just say n. So if all of them have, if we work it out and all have the same probability of occurring, then we could call that a uniform discrete random variable. So another thing to talk about is mode and median, which you should be familiar with. So the mode of a discrete probability distribution is the most frequently occurring value of the variable. So in this case, when we go back to our 2 coins, the mode is this value in here. so our half. And the median is corresponds to the 50th percentile. So what does that mean? Well, when we're listing the values in ascending order from, if the possible values are listed in ascending order, then the median value is a cumulative sum when the probabilities reaches 0.5. So when we add these values here that we've got, when these equal 0.5, and we could say that it's also here as well. Alright, let's look at one more example and then we'll leave it there for this video. Alright, so the example here show that the following function or when x is equal to 1, 2, 3, and 4 is a valid, that's the key word here, that it's a valid probability distribution function. Alright, so how are we going to prove this? Well, all we have to do is substitute in the values that we've been given for x and see if the answers all add up to 1. So let's have a look. We've got p of 1. So we've got 1 squared plus 1 over 34, which is just equal to 2 over 34. I'm just going to leave it as over 34 for the moment, even though it can be simplified. P of 2, which is going to be 5 over 34. P of 3, which is equal to 10 over 34, and finally P of 4, which is equal to 17 over 34. Alright, so let's add up these 4. So we're going to have P of 1 plus P2, probability 3 plus probability of 4, and hopefully that will equal 1. Let's see what happens. So we've got 2 over 34. Let's get 2 plus 5 plus 10 plus 17 all over 34, because, well, we're simplifying it a bit. We could put them all as fractions, but because they have a common denominator, we can just add them together. Another reason for leaving it as over 34. So 2 plus 5 plus 10 is 17. 17 times 2 is 34. So we get 34 over 34, which is equal to 1. Therefore, we say that probability of x is a valid probability distribution function. Alright, that's all I'm going to go through in this video. We'll go through a little bit more stuff in class. I'll go through another example where we can start off, and yeah, that's it. So thanks for watching, and we'll see you next time.